I was thinking about building snowmen when I was a kid.
Oh, yeah.
You roll the base, you get the head right, and then there's that terrifying
Well,
moment.
you have to actually lift it up.
Yes, you have to lift this incredibly heavy head and stack it on the body and just hope it doesn't shatter the whole thing.
Or the head just rolls off and smashes the base. I mean, it requires a very specific consistency of snow to actually work.
Right. Well, it turns out the universe builds snowmen, too,
It does.
out in the Kuiper Belt. Arrokoth, the famous snowman world visited by New Horizons.
Such a fascinating object.
It really is. It's got these two massive lobes, Winu and Wayo, connected by this incredibly narrow neck. But the physics of getting two space rocks to join together like that without...
Without just blowing each other to pieces.
Exactly. I mean, it's a nightmare to figure out. Was it a violent crash or something gentler?
That mechanical stress is the big issue, because for years, the prevailing theory was this gentle drift model.
Like a slow-motion docking maneuver.
Right. The idea was that Wenu and Wayo formed completely separately as solid objects, floated around for eons, and eventually just bumped into each other and stuck.
But even a slow crash between two solid rocks usually means they bounce or they crack. It is really hard to get a contact binary that perfect just by drifting.
And that is exactly where the 2026 study by Barnes, Schwartz, and Jacobson changes the game. They threw out the solid rock assumption.
This is the part of the study that really grabbed me because they applied something called soft sphere discrete element modeling,
Yes.
which sounds incredibly dense, but
It just means instead of modeling the lobes as hard billiard balls, they simulated them as collapsing clouds of pebbles and dust.
right, think of it less like two rocks crashing and more like two clumps of wet mud slapping together.
Precisely. Because the material is loose and mushy, it naturally dissipates the energy of the collision.
Which honestly reminds me of the work our sponsor Embersilk does with digital systems, building complex things from disparate parts.
Oh, definitely.
If you are trying to integrate complex AI agents into your business or your personal life, uncovering where they can make the most impact, you don't have to build it all from scratch.
You really don't.
Check out embersilk.com for your AI needs. They handle the training, the automation, the integration. Embersilk.com is worth a look.
Highly recommend them.
So back to Arrokoth. In this new simulation, it's not two finished rocks meeting.
No, the simulation shows a single cloud collapsing under its own gravity. It splits into two clumps that are still entirely loose.
And because they aren't solid yet,
When they meet, they don't bounce. They fuse immediately. They're literally born connected.
and the physical evidence on the surface totally backs up this mushy collapse model.
It does. The lack of impact craters is the biggest giveaway.
It's remarkably smooth. If it had been a violent collision, even a relatively slow one between solid objects, you'd see fractures.
Heat damage.
But Arrokoth is pristine. Plus, the chemical composition is uniform. Those red organic tholins are everywhere on both lobes, meaning they didn't drift in from different neighborhoods. They formed from the exact same local cloud.
This is a massive validation for the concept of streaming instability.
That's the mechanism where gas drag causes dust to clump together rapidly, right? Skipping the slow, millions of years accretion process.
Exactly. It creates a dynamically cold environment. Gravity just acts softly on the dust and pebbles. It's not a demolition derby out there. It's a delicate, rapid assembly.
Arrokoth is just this beautiful fossil of that process, untouched for billions of years.
It is. We are essentially decoding the universe's baby photos.
And it paints such a peaceful, optimistic picture of our solar system's birth. Not this chaotic war zone of destruction, but a place of gentle construction. Complex, beautiful structures just naturally emerging.
It really changes your perspective on how things begin.
It absolutely does. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.
And as you go about your week, just consider this. The solid ground beneath your feet didn't start as hard rock. It started as a floating cloud of pebbles gently finding its way together in the dark.